Hi everyone, this is Miss S from Excelsior Charter School, and today we're going to be covering Geometry, Lesson 3-2, Proving Lines Parallel. This is all the vocabulary that we're going to be going over today, and we're going to start with a flow proof. So we've learned about two-column proofs and indirect proofs and paragraph proofs, and this is just one other way that you can prove things in geometry. They use arrows to show you which way it goes, and it's a little bit odd, and we don't see this too often in geometry, but it is something that does happen occasionally. So all right, remember in Lesson 3-1 we talked about all the different angles that happen when you have two lines that are parallel with a transversal. Today we're going to be going over the converses of all of those postulates and theorems. So we're going to begin with the converse of the corresponding angles postulate. So the corresponding angles postulate says that if you have two parallel lines, A and B, then all corresponding angles are congruent. So angle 1 would be congruent to angle 2. The converse of this postulate simply flips it around. It says if angle 1 and angle 2, which are corresponding angles, are congruent, then the lines must be parallel. Our next one is the converse of the alternate interior angles theorem. So here we have two lines, L and M, and we have a transversal coming between them. An alternate interior, so angle 4 and angle 6, which are on the inside of the two parallel lines and alternating sides of the transversal. If the lines are parallel, those two angles must be congruent. That's what the alternate interior angles theorem says. The converse, again, flips it around and starts with the angles. If the angles are congruent, then it ends with the lines. The lines must be parallel. The same thing happens with the same side interior angles theorem. The theorem itself says that this angle and this angle has to add up to 180 if the lines are parallel. The converse says that if these two lines add up to 180, then the lines are parallel. So the theorem starts with the lines being parallel and tells us that the angles add up to 180. The converse flips that around. If the angles add up to 180, then the lines are parallel. The same here again. The normal theorem starts with the lines being parallel and tells us that the alternate exterior angles must be congruent. For the converse, we start with the angles being congruent and end with the lines being parallel. L is parallel to M. And our last one here, the same side exterior. So if angle 2 plus angle 8 equals 180, then line R must be parallel to line S. And that would be the converse of the same side exteriors. So in all of the normal theorems, you start with the lines being parallel and you end with the information about the angles. In all of the converses, you start with all of the angles and end with the lines being parallel. Good luck, everybody. I hope you guys do great.